Hello everyone, you're welcome to class today. Remember in our last class we talked about fractions, and in fractions we saw the three different types of fractions. So we saw proper fractions, improper fractions and mixed numbers. Today we'll be looking at how to convert from improper fractions to mixed numbers. Remember I told you you can convert from improper fractions to mixed numbers and from mixed numbers to improper fractions. So we'll see how to do from improper fractions to mixed numbers. Alright? Now what's the meaning of conversion? Conversion is simply a change. A change from one to the other. Alright? So conversion from improper fractions to mixed numbers. Alright? Now, from what we're seeing conversion from improper fractions to mixed numbers. Remember, I told you that improper fractions are fractions where you have something like a over b, where our a, which is our numerator, is bigger, greater than our b, which is our denominator. For example, we can have 5 over 2, I have 4 over 3. This is an improper fraction. But for mixed numbers, what do you mean by mixed numbers? Where you have a whole number and a fraction. For example, this is a mixed number. Another example, you can have 3 of this is also what? A mixed number. Okay? Now, like I said, we're talking about conversion of improper fractions to mixed numbers. Let's see some examples. A. Let's see the usual 22 over 7. Let's see B, 25 over 3. And let's see C, okay, 15 over 7. Let's pick the first one, 22 over 7. Now, you can quickly or easily say, how many 7s can I get from 22? Well, for some people, you might like to count out. Let's do it in the small space. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now let's group them in 7s and see how many we get. 1, 2, 3, 4, 5, 6, 7. This is 1. 1, 2, 3, 4, 5, 6, 7. 2. 1, 2, 3, 4, 5, 6, 7. 3. Remainder 1. So what do we have? We have 3 7s. Write down our 3 as a whole number. How many remainders do we have? Just 1. Now our remainder goes on top. Our denominator doesn't change. Okay? So this 3 tells us that we have 3 7s there. Remainder 1. Otherwise, if you feel this will waste your time, you can simply do this. Use a multiplication table. 7 times 1, we have 7. 7 times 2 is 14. 7 times 3 is what? 21. 7 times 4 is 28. Now look, we're looking at 22. 21 is lower than 22, but 28 is far greater than 22. So what do? We'll pick this first. And how many 7s can I have here? 7 in 3 places will give me 21. So I write 3 as my whole number. Now you check. 22 minus 21. 2 minus 1, I have 1. 2 minus 2, I have 0. So my answer is 1. So I can get 3 whole number, 1 over 7 as my answer. Okay? Now B. Let's see 25 over 3. 25 over 3. Okay? Now, again, if you are the type that doesn't know how to do multiplication, but I encourage you to learn your multiplication table. Okay? It makes your work easier and faster. Alright, let's see, we're looking at 3 times table. Why are we looking at 3 times table and not 25 times table? Now, what this means is 25 divided by 3. Okay? 25 divided by 3, 25 over 3. So we're looking at, since 3 is what will go into this number, that's what we now use as our multiplication, or if you want to use multiplication table, or if you want to use division, you count out and divide by 3. So let's count to 25. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So let's count in threes. Let's go. 1, 2, 3. 1, 1, 2, 3. 2, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. This is the remaining one. Let's see how many threes we got. 1, 2, 3, 4, 5, 6, 7, 8. Wow, we have 8 threes. Do we have a remainder? Yes, we have 1. 1. So we just have our remainder 1 all over 3. Now this it tells us that there are 8 threes in 25. Remaining 1. Okay? So let's use the multiplication table. If you feel bored or annoyed using this, let's use the multiplication table. Let's see. 3 times 1 probably give you 3. 3 times 2, 6. 3 times 3, 9. 3 times 3, 12. I'm very sorry. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. 3 times 8, 24. 3 times 9 will give us what? 27. I'll stop there. Why? Because 27 is already bigger than my 25. Can you see it? 27 is bigger than 25. But then the next number, 24, is smaller than 25. So we'll work with this. We'll now look at this and we'll say, okay, since there are 8 threes here, that is 8 times 3 will give us 24, which is smaller than this, and it's not up to 27. So what do? We'll pick up our 8, which is this 8 that we already have here. Now we'll see. We'll subtract. 25 minus what we have here, what do we have? 25 minus 24. 5 minus 4 will give us 1. 2 minus 2 will give us 0. So we'll have 0, 1, which is simple as 1. So that becomes my remainder. And remember, my remainder always stays on top of my division line or the quotient line. And this denominator doesn't change. It still remains 3. Okay? We'll do just one last example. Which is our 15 over 7 over here. See, 15 over 7. 15 over 7. Okay? Now, how many 7s can I get in 15? 15 is easy to count, isn't it? It's very easy to count. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 divided by 7. 15 divided by 7. Or 15 over 7. So now we're going to write or divide or group 15 in 7s. That is in 7, 7, 7. So let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. How many did we get? We had 2. 1, 2. What is remaining here? We have just 1. So write our 1 all over our 7 here. Otherwise, or alternatively, if you feel this is a waste of time, you can simply, again, use your multiplication table. 7 times 1, we have 7. 7 times 2, we have 14. 7 times 3 is 21. 21 is bigger than 15. But this number is also less than 15. So we take this one. How many 7s can I get here? It's 2. Why? Because 7 in 2 places will give us what? 14. So that becomes my big 2 whole number. Now 15 minus 14, which is the result of when you multiply 7 by 2, you get 14. Minus it, you get 1. This becomes my 1 remainder all over my denominator. It's that simple. Very, very simple. Alright, so I've seen 3 examples. I'll go over it again. Now, from what we're doing here, we're converting from improper fractions to mixed numbers. And remember, I told you that improper fractions are simply fractions where we have our a over b, where a is greater than b. I'll explain. It's not that difficult. A is called our numerator, b is called our denominator. Where the number on top of this quotient line, this is called the quotient line, where the number on top of the quotient line is greater or bigger than the number below the quotient line, we say it's an improper fraction. Okay, we call it an improper fraction. Alright, now when you have something like this, 1 whole number 1 over 2, we say this is a mixed number. How? Because you have a whole number, 1 being a whole number, and a fraction occurring at the same time. When they occur at the same time together, just like when they're together, we call them mixed numbers. Okay. Now we saw some examples. We started with 22 over 7, where we used normal counting method of counting 1, 2, 3, 4, 5. We counted to 22. Okay, 22 over 7. Now after counting out like this, this is not what we used. Counting out like this, we were able to pick out 3 7s. 3 7s from 22. The remaining, whatever we had, was not up to 7, so we left it because it was not up to 7. So what we had was 3 7s. And what did we have as a leftover? It was 1. We call it remainder. Okay, so we had 3, remainder 1. Right? So that's why we have 3 whole number 1 over 7. Why do we still maintain the 7? Because that's what we are working with. That's what we are dividing by. This is another way of calling this is 22 divided by 7, or simply 22 over 7. So our 7 still follows our equation, or rather our answer. Okay, we went on to see 25 over 3. Again, we counted out and we got 8 3s from 25. What our remainder was 1. So that's how we had this. Alternatively, you could use the multiplication table, where we had 3 times 1, 3, 3 times 2, 6, and continuously. We saw that 3 times 8 was 24, or is 24, right? And 3 times 9 is 27. But 27 is bigger than 25, and 24 is less than 25. So what do? We pick that 3 times 7, 3 times 8, which gives us 24. So we have 8. That's how we got this, our 8 here, because the 8 3s in 25, okay? Right, that's our whole number. Now we'll minus 24 from this number, and we got 1. That's our remainder. So either ways, you can either use your counting out method or use your multiplication table. Okay, multiplication table, if you know your multiplication table, it helps you to, in fact, it reduces your problems. It reduces the time you use in solving, reduces your stress. Okay, I encourage you, learn a multiplication table. Okay, the last one we saw was 15 over 7. Again, we divided, it's still on the board. We counted out rather 15, and we grouped them in 7s. And in 7s we have 1, 2, just 2 7s in 15. What was our remainder? Our remainder was 1. Alternatively, we use the multiplication table, where 7 times 1 is 7, 7 times 2, 14, 7 times 3 is 21. It's bigger than this. Okay, so we picked the one that is less than it, and that's 14. We minus our 14, or we subtracted our 14 from 15 and got 1. Again, 1 over 7. It's just a coincidence that we're only having 1. You can have a situation where you have your remainder as 2 For example, if you are working with a question like this. You're working with a question like 18 over 3. No. 18 over 5. Let's use 18 over 5. Okay? Now, I can count out my 18. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. Alright, that's 18 over 5, meaning 18 divided by 5. So we'll group them in 5s. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many 5s did we get? We got 3. What's our remainder? Is this up to 5? The answer is no. So we write it as our remainder. 3 over 5. Again, you can use your multiplication table. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. So 20 is bigger than 18, but 15 is less than it. So we'll work with our 15. How many 5s can I get from here? We have 3. That's our whole number. When I subtract 15 from 18, I'll get my remainder as 3. So that's how we got our answer as 3 whole number, 3 over 5. Watch out for our next class, where we'll be seeing how to do the alternative, yes, where we'll be converting from mixed numbers to improper fractions. See you.